seltzers and nutrients required for seltzer. It'll make more sense when I get there, but so that's kind of what we're going to talk about. Just a little bit of background myself. You've heard me talk before, you've seen the slide, but bachelor's from the University of Illinois in microbiology, and that's where I actually started homebrewing. They have a very, at least at the time, it was a very active club called Buzz. That was the actually an officially university sanctioned homebrew club. And there were members of the food science department that actually banked a really, really large yeast collection. So it's really kind of started getting hands-on experience building yeast, and even took duplicates of a lot of that with me when I then moved from Champaign down to Houston to go to graduate school. And that's where I got a PhD in microbiology and molecular genetics from UT Houston. And actually studied Saccharomyces cerevisiae there for my PhD, though it was in the realm of human health, using yeast as a model system, because we actually share a lot of genetics with Saccharomyces. So much so that you can actually even take human genes and replace the yeast version of certain genes, and they will perform the same function. Might do it vice versa, but that's probably unethical. So from there, though, I went, left the bench and went to the University of Houston School of Law, where I got a JD, and ended up moving back to Chicago, where I was a patent attorney, specializing in biotechnology patents at Marshall Gerstein and Bourne for 4 years. And that's it's in 2013 when I saw the light and realized that it was no fun being an attorney, and started Omega Yeast along with one of my lawyer colleagues, Mark Schwartz, who's not a microbiologist, but is an electrical engineer and has a little bit more, business sense, I suppose. So that's kind of how we ended up splitting our tasks. He deals with business related things, and I deal with operations and innovation and things like that. So that was in 2013. We've grown pretty quickly from there. We started out in about a 1,300 square foot space in a costume company building, which is really weird. And then I moved right next door. There happened to be a building that was for sale around the time we were outgrowing our space. And so we bought that up, but then started outgrowing that pretty quickly. And then moved into our new building, which I have a couple pictures of after these slides. But as you probably already know, we prop and ship brewing yeast to microbreweries all over the country. We also package for home brewers. We ship a decent amount international. We're always looking to create and develop new brewing yeast strains by hybridizing is one thing. We get, certain yeast cells will mate under the right conditions, so you can combine traits of different strains. So we've done a lot of that, and we're actually, you heard it here first, we're going to be releasing our first couple of modified strains within a couple weeks. Not quite ready to tell you exactly what those are, but if you pay attention to our Facebook page, you should see in a couple weeks what will be our first genetically modified Saccharomyces cerevisiae brewing strains. We do basic differential plating for breweries, so testing for contamination, provide advice on strain selection, fermentation parameters, and we bank proprietary strains that people happen to come across, and hold on to them in -80 and grow them up whenever they want them. So as I mentioned, in just July of this year, we moved into our new building. So yes, we were in the height of building when the pandemic started, which was, nerve-wracking. I'm sure everybody has their stories about troubles, but that was actually largely happened on time, which I think is quite amazing. But so we ended up done enough that we could move in July. And this is looking into our cellar area, so our bigger propagation tanks. One of the big differences when we moved, in our old space, we had a 15-barrel boil kettle, and we just used dry malt extract as a growth medium for our yeast. So we just prepared 10 Plato wort out of dry malt extract. But the new building was built completely around being able to create our own wort. So we're effectively a brewery as far as creating wort. We have a 4-vessel system made by Ager. They're headquartered in Wisconsin, not terribly well known, but they make very good equipment. And they utilize the Mura mash filter instead of a lauter tun. So that's what you see. This blue device here is a mash filter. So rather than creating a bed that you drain your wort through, we actually essentially press our wort, and you get ridiculously high efficiencies this way. So you can get effectively 100% extraction efficiency from your malt, and then this little chute on the bottom spits it out via air assisted into a spent grain silo where farmers can come pick it up. We actually, if we were a brewery, we create around 45 to 60 barrels worth of wort a day, 7 days a week, 365. So we are one of the bigger breweries in Chicago, but nobody would ever think about that, especially since we tend to just dump all of our beer down the drain when we're done and keep the yeast. And it's no big loss. It's not very good beer. It's highly oxidized since we're pumping air into our fermentations the whole time to maximize yeast growth. And again, it's just made a 100% base malt, so not a great beer at the end of the day. That is a view of our. So part of the building is 2 stories where we were able to expand our R&D. So we have a dedicated R&D lab now, which is great. Basically, when the old building, everything R&D and production lab related happened in the same space, and it was very crowded. But now we'll be able to expand R&D and really push that. And here you can also see our silos. So on the left is the incoming base malt silo, and the right is the spent grain silo. So that's where we are now and have been there since July. So that, again, you've probably seen that. We'll give you the real quick, just general background on Kveik, which if you saw me talk before, you would have seen this slide. But what is Kveik? It's literally, the word means yeast in a particular Norwegian dialect. And one of the interesting stories around that was the first place that Lars Marius Garshol, who really obviously is fundamentally important in bringing the attention of the world to Kveik, he stopped at Voss, a farm in Voss, for his first trip. And that Kveik is what that farmer happened to be calling his yeast. He ended up, of course, going to many other farmsteads in Norway, and a lot of them, they had something like 3 or 4 or 5 different words for yeast, but Kveik was the one that what they were calling it in Voss, so that's the name that ended up sticking. But it really, it could have been any one of these other names, and frankly, this is one of the more pronounceable versions of the word, so I guess we should be grateful that he stopped there first. So these are cultures that have been passed from generation to generation, and they are very, very literally farmhouse yeast. These are not, until more recently, were not used by commercial breweries to make beer. They were stored on things like you see on the right here, Kveik rings. It's just basically pieces of wood that give you a lot of surface area on which to dry the yeast. So the yeast are very desiccation tolerant. After they pull this thing out of the wort, the yeast will dry under this ring, and then the next time they brew, they dip it down into the wort, and that's what inoculates the beer. They share some common features. Generally, they are very high temperature tolerant. That's kind of what they're known for. Most of them are flocculent. You do find some that aren't very flocculent. They're, as a rule, non-phenolic, and they're generally very high alcohol tolerant. Not unusual to get, it's possible to get up to 15-16% alcohol. And of course, fermentation temperatures are very warm. I think they describe it as something like milk temperature. So basically, and what they mean by that is, milk coming right out of the cow. So, body temperature. The beers they're actually brewing in Norway, they tend to be juniper infused mash water, very long boils, not much in the way of hop character. They have very rapid fermentations, 1 or 2 days, and it's generally very high gravity wort. And again, they store the yeast on either those rings like you saw in the prior picture or things called kveikstokker, which are basically logs that have lots of holes drilled in them with the idea of giving a lot of surface area on which the yeast can attach and dry. And they use those to inoculate following batches. And in some places, they scream into the fermenter. And I think there are versions of this on YouTube. If you're so interested, you can find versions of this. I guess meant to, ward off infections or something like that. So whoever it was that had a bad experience with Lutra, maybe you didn't scream. Had you screamed, it probably would have been fine. Okay. So how are these yeasts related to other yeast? What you see on the right is essentially a wheel that, however, if you're close to another strain here, that means you're closely genetically related. You have fewer differences in your DNA than a strain that's on the other side of the wheel. So what you can see in the red is where all of the kveiks tend to cluster. So they cluster very close to the Belgian and German lineage of ale yeast. But interestingly, if you look in the upper right, you will see some, I can't quite see it because the thumbnails are in front of it, but you'll see, for example, Hornindal 1, H1 in the upper right, and Hornindal 1, H2 in the lower left. And what that basically means is there are, some of the genetics are actually more closely related to wild Saccharomyces cerevisiae. So the thought is that there's actually, these are hybrids of, industrialized brewing yeast that came into contact with a wild cerevisiae. So because you have, genetics from both of these lineages there within the same strain. So that's the best evidence we have that these are hybrids, and it's probably why they have some of these kind of unique characteristics, because, they have genetics that are unrelated to domesticated brewing yeast. But of course also have a lot of features closely related to domesticated brewing yeast. So they are, as I mentioned, they're very ethanol tolerant, and that's what you see on this slide. So this is a kind of microbiology trick that we do where you take a culture and spot it onto a petri dish, and then you have a serial dilution of that culture. So each spot has half as many cells as the prior spot. And what this allows you to do is kind of tease out growth differences under different conditions, because the differences become more apparent when you have fewer cells around. So we have a selection of strains here, and we're testing their alcohol tolerance. So these are just kind of general yeast growth medium spiked with 8, 10, 12, 14, and 16% ethanol. And of course, what sticks out to you here is that the kveik grow, some of them anyway, like Hornindal, Voss, and Hothead, all are growing out to 16% alcohol. Wine yeast are known for being very high alcohol tolerant as well. So you see wine yeast growing out to that level too. One thing I'll point out is some of you probably brewed, Chico, imperial stouts with Chico that are greater than 10%. So a lot of yeast will actually produce beers that are higher than their ability to grow under that condition. So basically, they'll grow until they reach, say, 8 or 10%, and then stop growing, so stop making new cells, but continue to metabolize and pump out ethanol. So that's how you can get beers that are higher alcohol than they can tolerate in their growth. And that's what makes these kveiks so remarkable. Is not they are able to actually continue making new cells even when you're out to 14 and 16% alcohol. So they're not just, it's not just the existing culture pumping out more ethanol. They're continuing to reproduce when they get to these very high alcohol percentages. And not many ale yeast can do that. You've heard, of course, all about their heat tolerance, and that's what you can see here. So again, the same idea, and here we're just allowing these plates to grow at different temperatures. All the way up to 107 degrees Fahrenheit, you can see Voss and Hornindal are still, again, making new cells. hothead, the first Kvike we released, is really kind of struggling at this point. We found it to be actually one of the wimpier, I mean, it's still not very wimpy, but one of the wimpier Kvike strains. So it's just kind of struggling at 107. But none of the other strains here, the wine yeast, none of these other strains are growing or even trying to grow at 107. Everything grows fine at 30 degrees Celsius. That's really the preferred temperature for any yeast, ale, lager. They all grow very happily at 30 degrees Celsius, 86 Fahrenheit. Interestingly, from what we can tell, the Kvike are actually cold tolerant as well. So they're growing essentially as well as the German lager yeast here at 8 degrees Celsius, 46 Fahrenheit. Whereas, the Conan is not, London 3 strain is not. So, they're growing slow. So I'm not saying, run out and try making lagers at 50 degrees Fahrenheit with these strains, but they are tolerant to low temperature. And low temperature is a stress for yeast too. So the theme here is that Kvikes are stress tolerant. So whether that's heat, cold, ethanol, they can tolerate stress much better than your typical ale yeast. So to dive into kind of an anecdote on how we found Lutra, what we call Lutra. That's not a traditional name. It's just the name that we assigned to the strain. We were at a trade show in Ohio, and one of our customers brought up a canned beer that he was selling as a Pilsner that it turned out he had made with our Hornindal culture. Hornindal is a blend of a lot of different strains. And, most up until then, we had really just mostly been pushing the temperature with that. And, when you do that, you tend to get very fruity beers. So this wasn't an area we had really explored, but it kind of opened our eyes to the possibilities. And our thought, rather than, just advocating for the usage of the Hornindal culture at low temperatures to produce these beers, our thought was that maybe there was a strain within that multi-strain blend that was capable of a clean fermentation across the typical Kvike fermentation range. So we went about tearing the Hornindal culture apart to try to find a strain that fit these characteristics. So the step one was to, so what you see actually on the right here is a medium called WLN. It allows the growth of essentially any yeast bacteria, but it has a dye in it called bromocresol green, and different yeast for unknown reasons will metabolize or take up or not take up this dye differently. So it tends to be a very useful medium for determining if you have a mixed culture. You can take your culture and you streak it out on this plate so you get these isolated colonies, and an isolated colony arose from a single cell deposited on that spot. And based on what that colony looks like, whether it's white or green with a white rim or white with a green rim, you just see all sorts of different characteristics on this plate, so that you can at least start by plucking as many strains as you can see in there that look different, just that literally look different. They're white or they're green or what have you. So we did that, and you can kind of see that when you have these isolated and struck out by themselves, you can see kind of a panoply of different traits. You get 7F, for example, that's a super dark green. 8G is getting close to white. You get pale green. You just get a bunch of different looking yeasts, and you can be fairly confident these are unique strains, all buried within this Hornindal blend. So step one was finding as many unique looking yeasts as we could, but that doesn't tell you the whole story. So the next thing we did was a little more genetic analysis, and that was, we did what's called interdelta analysis. So all yeasts have repetitive sequences of DNA within their genome, but it happens to be kind of randomly sorted throughout the genome, and it has different sizes around the genome. So you can amplify these repeated sequences, and then when you run them out on this DNA gel here, you get different band patterns, depending on the size of these chunks of DNA that were amplified. So we did this with all those original isolates and compared band patterns between them. And if a strain had an identical band pattern and an identical WLN behavior, in other words, band pattern looked the same between two strains and they were both white, we would call that the same strain. So those two things that we'd isolated thinking maybe they were different are the same. So that's assigned one strain. If it had an identical band pattern but different WLN behavior, in other words, we see the same band pattern on this, but on the streaks before, one was green, one was white, those are different. So just because they have an identical genetic pattern, there's clearly some other genetic difference that's just not picked up by this test because they look very, very different on this WLN test. So we considered those two to be unique strains. And if you had a different band pattern, but identical WLN behavior, in other words, two white strains, but you had different banding patterns, we would consider those to be different strains. So using this analysis, we isolated 9 unique strains. And at that point, we drank a lot of beer. So we brewed, lots of wort and split it in 9 ways, and just had a blind tasting to find a strain that we thought had the characteristics we were looking for, which is to be, very clean, not too many esters, and had these characters at a wide temperature range. So as a result of this, we released what we call Lucherkveik. So that was the genesis of it and how we got to it. So this is one of the results of our R&D program. Are there any questions? Yeah, we'll go into something else after this. So maybe I'll pause briefly if anybody has any questions about what I've talked about so far.
If you do have a question, make sure you unmute yourself. I went through and pretty much muted everybody because of background noise.
Well, I have a question. When you do like these 9 different unique strain brews, what scale are you brewing on? Like a homebrew scale? Are you brewing on a more of a commercial scale? A 5-gallon batch or a couple barrels or what?
We have a 1-barrel Blackman electric system that we use for our pilot systems. So, a lot of times we'll do 6 5-gallon splits, for example. So yeah, that's what we use primarily for our pilot testing.
I have a question about blends because you suggested that Hornindal in and of itself was a blend, but we can talk about it later if there's going to be more stuff about those kinds of things.
No, go ahead. It's a good time.
Well, if you're producing a Hornindal to sell commercially, are you just continuing one population of mixed cells, or are you growing each one up and then blending them back together in specific proportions?
Yeah, so we do it both ways. With Kveiks, we do it, so we have our freezer stocks, and then we'll streak out of the freezer onto a plate. And at this point, good microbiology would tell you to pluck a single colony to start your culture to grow up and have a uniform culture. But if you're trying to maintain a blend, that's not a good idea. So what we do with the Kveiks that's different is we make sure when people are starting cultures, they take a wide swath on that plate so that we're plucking up a random assortment of strains. And we take other steps that are different. So with other strains, we will, once we've pulled that out of the freezer, we will exhaust a plate, but then streak from that plate onto another plate, and we'll do that 2 or 3 times. But with these, as soon as that plate's exhausted, we go back to the freezer. So we do and start this whole process over again. So everything we do with these blends like this is meant to try to keep them, as the random assortment of strains they were when we got them.
So theoretically, your Hornindal could vary batch to batch a little bit.
I mean, it could, but taking these measures, we hope is enough to prevent that. And with other blends, so for example, getting out of the Kveiks, we have a lot of customers that use blends of their choosing. So one of our most popular blends we're making all the time is the Conan strain, along with the British 5, what would be the London 3 strain. So lot of people like the haze they get from the British 5, but they like the slightly more attenuation they get from Conan. So we'll blend those. And those we grow completely separately and blend them at the end. So it really kind of depends, but Kveiks we generally grow as a blend. Other strains, other blends customers order, we grow separately, blend at the end.
Out of those 9 strains, have you found anything else that's, you know, fun or interesting that you plan on doing anything with?
That needs more work. So we have just lots of projects going all the time. So that kind of, we kind of forgot about those once we had what we were looking for here. We have, so that's on a list, but not super high on the list.
Yeah, that's fair. Cool.
So I guess briefly, I think it was suggested I talk a little about so the other more recent Kveik that we have is called ESPE. That's E-S-P-E. He might have said ESPE. That's how I used to say it until I asked Lars how you're supposed to pronounce it, and it's ESPE. So when we got that, we brewed with. We actually had Lars send us a collection of Kveiks. I think 5 strains in one shipment that we chose really based on the descriptions that he had on the Kveik registry, the ones that sounded interesting to us. And when we got them, we did the same thing. We had the 1 barrel pilot, we brewed, we split it up, and we really liked what we were getting from the ESPE culture. It was just had a unique fruitiness that we weren't getting in the other ones. The other ones kind of all tasted similar. I mean, all these strains tend to be genetically related, so it's not surprising that some of these farmhouses would have ones that are very similar to other ones because they probably literally got it from the other farmhouse. But that one stood out to us. So we started making that one available, and then we had a customer note that a pack smelled a little phenolic, and we're like, well, that's odd. It shouldn't be phenolic. We'd never perceived that in the test batches we did, but I opened a homebrew pack we had sitting in the cooler. I'm like, this does smell a little phenolic. So we went back to the culture that we got straight from Lars. We did the same thing we did with Hornadal, struck it all out for isolated colonies, grew them all up individually. And what you can do with to test for phenolic yeast is take a Petri dish, spike it with ferulic acid, which is the precursor for the 4-vinyl glycol, which is what we smell as cloves. So phenolic strains will take the ferulic acid and convert it to 4-vinyl glycol. And so you can literally streak these yeasts out on a plate, and after 2 or 3 days, sniff the plate, and does it smell clovey or not? It's as simple as that. So we did that, and much to our surprise, we found a phenolic strain in that blend. So from that day, we actually reconstituted the blend without that strain. So ESPE is not the original farmhouse culture. Where we have in the long term, again, one of these very long-term plans of looking more closely at the genetics of that phenolic strain, because it's probably not a true Kveik, because Kveiks are all genetically incapable of converting ferulic acid to 4-vinyl glycol. So it's probably not a Kveik. It's probably some sort of other wild Saccharomyces or another brewing strain that got mixed in with the ESPE culture. But it doesn't seem to be too terribly dominant, because most of the time we don't perceive phenolics in that. I mean, again, we could smell it a little bit in that pack, but the beers we made with it, we never smelled it. And it was definitely in that original culture. So depending on, if you've used Kveik, depending on when you got it, you may or may not have had similar experience. Any questions about that? Okay. So there are a lot of, I don't know what to call them, old wives' tales about Kveik, and some very strong opinions on the proper way to use them. And one of those is that you absolutely have to underpitch them. If you don't underpitch them, they don't work. They're not going to give you the right results. They're not going to be fruity. So the Escarpment Labs in Canada looked into this a little bit. as far as pitch rate effects on fermentation kinetics, so how fast they'd ferment, and the esters they'd make, the organic acids they'd make, see if there was a connection between pitch rate and these characteristics. So that's what you're seeing here. This is the fermentation kinetics. This was done at, I think, 70 Fahrenheit. This is one of the things they got a little grief for, which I don't think was fair. I mean, there are different questions. But anyway, the way they set this up was had a model wort that they pitched at 1 million cells per mil, 7 million cells per mil, 10 million cells per mil, and then tracked their fermentation time. And what they found was that you pitch less yeast, it takes a little longer. I mean, it would catch up. So they're pretty tolerant of underpitching, but you know, they're a little slower. So they certainly weren't faster when you pitched them at lower pitch rates. So if that's one thing you might have thought going into it, that Kvike, you know, do better when they're underpitched, that was, you know, kind of debunked with this experiment. As far as their organoleptic properties, they did the same thing. Pitch rates different, fermented out, and then measured a slew of organic acids, esters. I'm not going to go through every bar, but if you studied all of this, basically it was all over the map. Sometimes there was a pitch rate correlation. So if there was a higher pitch rate, they'd get, well, just one example, Hornindal. And the first one, ethyl octanoate, they got a higher amount of that at the underpitch than they did at the higher pitch rate. But Voss, for example, you know, doesn't seem to have any sort of correlation between output of ethyl octanoate and pitch rate. So there are some strain-specific differences. So really, they did not see any pattern here on the output. Some of the interesting things that they did see is a lot of people have described Kvikes as being creamy in some instances. And these last two things you see here, hexanoic acid, octanoic acid, can give you kind of a creaminess. And those are significantly higher, really almost across the board compared to the Conan strain. So that's probably the source of that feature of Kvikes. I don't know.
Anecdotally, my use of Voss, I get the same kind of a thing, that even at low pitch rates and high pitch rates, I still get a very similar ester profile throughout.
Yeah. I mean, I'd say what we see is agreement to that. We're hopefully getting a fancy piece of equipment sometime in the new year that we'll be able to have a machine tell us if that's the case too. So we plan on doing a lot more studies like that, and again, varying, you know, temperature and all these other variables to see, you know, to get better than an anecdote, right? And to have actual controlled experiments tell us what we're seeing across different situations. I see now, I should have looked at these a little closer because I duplicated two of them, ethyl octanoate, these are the same. Anyway, so here are some different things on the beta citronellol, which is, so the yeast can take geraniol, which is present in hops, and convert it to beta citronellol, and that is one of the things that yeast does that's considered, you know, biotransformation when you hear this term thrown around. Some of the Kvikes seem to have the ability to biotransform geraniol to beta citronellol. This RSET Kvike that they have seems to do that, whereas the Voss did not. And then, you know, you look across the board here too, you see, you know, ups and downs and no clear correlation between pitch rate and output. So there's no magic formula for, you know, underpitching Kvike to get the result you're looking for. If anything, there's going to be some strain specific differences. So you're probably going to have to experiment if you're wanting to, you know, find what works for you, what you're looking for. Switching gears a little bit, they looked at pitch rate effects and free amino nitrogen consumption. What they did find was that Kvikes, especially when they looked at their broader collection, had higher fan requirement, their higher fan consumption. So they would regularly consume, in this model, we're at 180 parts per million of the fan, compared to, I think, an average of around 150 for typical ale yeast and lager yeast. So they do seem to be needier for fan, but again, no real correlation in fan consumption and pitch rate. They consumed more fan, but it wasn't dependent on pitch rate. Terminal pH is, if you've used Kvike and you're a habitual measurer of pH, you may have noticed that a lot of Kvike tend to drop the pH of the wort more so than other ale yeasts, and this is certainly something we've seen. As a matter of fact, when we first isolated Lutra, we brewed a Helles alongside our Bayern lager, and the Bayern lager finished around 4.45, I think, pH, and the Lutra was 4.1. So Kvike definitely dropped the pH pretty significantly. And that's what they saw when they did a broad survey of their strains, whereas most ale yeasts would typically finish around 4.4 or so. The Kvikes tended to, as a rule, finish with a lower pH. So one thing we need to look into a little more, and some things they've done, are modifying the starting pH of your wort to kind of counteract that, so that you end up with a pH, a little closer to typical, and then with the hope being that it ends up tasting a little more typical. But again, that's something we need to look at a little more closely.
Back to the previous slide, I think, where you mentioned something about alcohol. Have you guys, so we did a study, or we helped Bell's do a study about dry hop and dry hopping beer and getting ABV creep. Have you, on the east side, on the yeast side of the industry, done any studies to see what dry hopping may do to the yeast to generate the ABV creep?
I think the yeast's role in that is essentially, once the enzymes in hops have broken down remaining dextrins or starches, they're there to ferment it. We have had a customer tell us he's been experimenting with, I guess the different variable with Kvike is that you're tending to do your fermentations very warm. So it's theoretically possible that the enzymes function a little faster when you're doing, say, a very warm fermentation dry hop. But they saw creep even when they did that. So that didn't seem to be an effective way to stop creep. It's mostly a hop phenomenon, really. If your hops happen to be, depending on how they're processed, and they have amylase enzymes, they'll make that those glucose units available, and the yeast that's remaining in suspension will ferment them. They don't seem to be too terribly prone to diacetyl under these conditions, where some yeast definitely have that problem. When you get hop creep, you get a spike in diacetyl, and I haven't heard too many reports of anything like that with the Kvikes. I don't know if that answered your question.
No, it did. It's interesting. Thank you.
So early on, when we were kind of exploring some of the nutritional requirements of Kvike, we did this experiment, which was basically to see if they could tolerate very low levels of fan, if they could tolerate different types of nitrogen. So in these plates, the first plate is amino acids. Everything's totally happy on amino acids. Urea, gelatin, and the remaining ones, we used diammonium phosphate as the nitrogen source. So not organic amino acids, but inorganic nitrogen. And if your only source of nitrogen is DAP, the yeast has to actually synthesize all of its amino acids from scratch. So there are no exogenous amino acids available. They have to make everything from carbon and nitrogen. So what we saw in this is that the British 5 and Chico yeast actually didn't matter how much DAP you use, they could not grow. What this suggests with those strains is that they are unable to make at least one essential amino acid. So they would not grow under this condition. but Voss and Hornindal actually were tolerant of pretty low levels of DAP. So yeah, so this was a little surprising. We were kind of expecting them to be, you just saw that they consume large amounts of FAN. So we thought that would mean they'd be not very tolerant of low amounts of FAN, but they're growing, not that bad at 25 parts per million FAN. One of the hardest results, it's just an aside, but one of the hardest results to explain here is why French Saison and wine yeast are growing in zero FAN. And that is probably one of those components of the media is contaminated with at least a little bit of some sort of nitrogen source, because pretty sure there's not an organism on this planet that can grow without nitrogen. And we see that all the time. There's agar, for example, has small amounts of sugar in it. So you can make plates with no sugar added and you'll get a little bit of squeak of growth out of it. And that's because the agar has some stuff in it. So it makes these sorts of experiments very hard because all your reagents tend to be contaminated things you don't want them to be contaminated with. So this actually ended up, it was this line of experiments that looking at nutritional requirements of Kvike happened to be around the same time that we're getting more and more inquiries about seltzer and how to make seltzer and get reliable fermentations with seltzer. So we went about developing our own seltzer nutrient with the goal of it being to avoid off flavors. So if you've ever tried making seltzer, you may have had some pretty stinky fermentations. Not unusual to get a lot of H2S out of it. We've had reports from a lot of people having extremely slow fermentations. It'll take, it'll ferment out, but it'll take 25 days. Or it won't ferment to completion, or it has weird colors. So we wanted to kind of solve this problem, make a nutrient that would be useful for beer yeast, essentially useful for any yeast, but since our customers tend to be breweries, they want to use the strains that they have around. So we focused our energies on finding a nutrient that would be useful to use with ale yeast. So one of the ways we did that is actually kind of related to that plate you saw before, and did lots of experiments where we used organic nitrogen, and that was in the form of yeast extract, as well as inorganic nitrogen, so that we could make sure that all ale yeast that we tried would grow. So yeast extract will supply all of those amino acids. This is what yeast extract is essentially ground up yeast without their cell walls. So clearly it has everything yeast would need to grow. So we balanced the nitrogen in there with inorganic and organic, and found one that works very well. This is, again, why you need nutrient. I mean, I think one thing that brewers don't necessarily appreciate is the sheer amount of nutrients that come from wort. I mean, they are chock full of vitamins, nitrogen, minerals, phosphates, potassium. All this stuff is in huge abundance in wort. So if you take sugar, just dextrose or sucrose, dissolve it in water, chuck some yeast in there, they're not going to do well. And also, if you just take your beer nutrient that you might use every once in a while when you're doing, say, an adjunct heavy beer, and use that recommended amount in there, it's probably not going to be remotely enough, because again, there's probably well over 1,000 parts per million of all these other things, just ignoring sugar, of all these other nutrients there in wort. Whereas the typical dosing regimen for a beer nutrient is probably on the order of 20 to 50 parts per million. So you're, again, not supplying remotely enough nutrients if you're spiking under those regimens. And this is what happens if you do no nutrient, and if you do the nutrient that we developed and we used in this case with Lutra. So we got from 10 Plato to under 0 in 2 days when we ferment very warm. So big difference in whether you do an adequate amount of nutrient or not. So this is actually going to be available to homebrewers and pro brewers here in the next week or two. We're calling it Proper Seltzer, kind of extending our line of brewing aids, the other one being Proper Starter, which is, canned high gravity wort. So this is Proper Seltzer, developed, again, what started as just looking at Kvike nutritional requirements, ended up going down this road and developing this seltzer nutrient. And it's going to be available in 5-gallon pitchables, effectively, basically an amount that's appropriate to brew 5 gallons of seltzer. So you just throw this in at the end of the boil to dissolve and pitch your favorite yeast and ferment away, and add whatever flavorings you're looking for. It provides organic and inorganic nitrogen, as well as minerals and many, many vitamins. Available in 5 gallon, 7 gallon, and 15 barrel pitchables. This is one experiment we did where we did different dosage rates of the Proper Seltzer and different starting gravity. And you can see what sort of things it's capable of. Again, in this situation, we got 16% alcohol with Lutra in a pretty quick time. One of the very interesting things that came from this, we sent these resulting seltzers out for analysis for esters and fusels. And so even when you triple the alcohol output, you don't triple the fusels or the esters. And what that means basically is if you want a more neutral seltzer, you should do a high gravity ferment and dilute it back. Because when you do that, it actually tastes, you get the same ABV. So say you start at 10 Plato and ferment that out, and you end up at 6%. Whereas if you did a 25 Plato and then cut that back to 6%, it's going to taste more flavorless if you do the high gravity cut back. And really, seltzer, as far as what people are looking for from us, people are more looking for something that's very neutral that they can flavor however they want. And if that's your goal, that's one of the better ways to get a very, very flavorless base on which to flavor however you want. Yeah, so that was it out of the presentation. If there's any questions specifically about this, I can answer that. But then I was fed a few other questions that I guess you guys wanted to discuss as well.
No, thanks for about the Proper Seltzer, because I saw there was an advert in this month's Zymergy about that one. So I contacted one of our local homebrew stores and said, when are you going to start carrying this? Because I can just see a pretty good seller.
Yeah.
Now that's what were you saying about the fermentation temperatures for the seltzers using this?
I mean, a lot of times with these, we're doing 30 Celsius, 85 Fahrenheit.
Right on.
With Lutra, I mean, with other strains, you might get a little more fusily at those temperatures, but with the Kvikes, we keep them pretty warm. Just to, again, the goal in this case being speed and flavorlessness.
Yeah. That's a pretty startling graph you've got there. It's
yeah, if you can keep the temperature up, these are very fast. We've been pretty thrilled with this nutrient. We've compared it to a lot of others, and I mean, a lot of others haven't been designed specifically for this. They've been designed as supplements for high adjunct wort, things like that. But this was really meant for having zero nutrients. Specifically, it's a weird time we're living in, but this was, seltzer is really growing, so we put a lot of energy into this.
Awesome.
It's the Soylent of the brewing world.
The Soylent, yes.
So I'm going to be greedy and get a couple of questions in before Brian probably inundates you with a ton of questions, because Brian's done a lot of work with Quikes in the past. So
we'll just keep him muted, David. Go ahead.
But So basically, going back to Lutra, and with Tim's experience, and I've had another friend who tried fermenting Lutra warm because he wanted to get a fast fermentation, and then looking at some of the other experiences online, and I know kind of opinions online can be variable. I'll keep it clean, but so I wanted to do like a clean American Pilsner type thing.
Mm-hmm.
So I fermented it around about normal ale temperatures, probably a wee bit colder. So early mid 60s. From the taste I had of the beer, but basically before I carved it up, it seems to be a very clean fermentation. My one friend who tried fermenting with Lutra and fermented a bit warmer. I think he tried to push it to get a quick fermentation. I think he was trying to see how quickly he could go from grain to glass.
Mm.
I think he got from grain to glass within a week. But he reported. He said, it's a really clean fermenter. To him, when he tried fermenting it at a bit warmer, so 90 something, he reported that it was very much like he was brewing with US05 or SO4. So it was a very clean, almost kind of like American or English styles. It was more of a the way he described it. It was more of an ale rather than the crisp, clean lager that he was looking for. So, I was wondering if you had any comments about your experience with how the temperature can affect the flavors you get from some of these things.
That sounds consistent with our experience. I'd say the upper end of that, I'd say it's more Kolsch-like. It's so it has a fruity note to it, like you said, around like US05, something like that. So I'd agree with that. If the more lager-like you're trying to get, I still think it is better to keep it, at kind of typical ale temperatures. So keep it in the 68 to 72 range seems to kind of cut back a little bit on those esters. So that's consistent with our experience and the guidance we provide on our on the descriptions for that as well.
Thank you.
Yeah, and I wouldn't say we, have completely solved it either. It's something we're still looking at. One thing that seems to be a little inconsistent is clarity with it too. There's some people have, and you can see YouTube reviews of it where they have a crystal clear, beautiful looking beer, and then other people that have kind of a persistent haze with it under some conditions. And I don't know whether it's malt variation or water variation. There's just so many variables that can get hard to track down. But if people are experiencing it, we want to get to the bottom of it and figure out how to get haze when you want haze and how to prevent haze when you don't want it. But we're not there yet.
Right on.
So I've got one more question, I guess. There is the on Facebook, there is the Omega Yeast brewing community. Is that anything that you endorse, or is that just a bunch of users just sharing their experience? Is that something that you would recommend as a basically as a resource at all?
Yeah, I think if it's anything coming from us, we try to be pretty clear that it's coming from us. So I guess I don't necessarily endorse the opinions of people who aren't us, but even a lot of times the people answering those are asking me before they post those sorts of things. So it should be our official position if it's posted by somebody from Omega.
Thanks. Wow, I'm surprised that Brian's being quiet.
You told him to.
Yeah, I don't think he's at his desk right now.
That might explain why then.
Oh, I was muted. Sorry.
There you go. Go for it.
No, partially I'm in the middle of eating dinner, but
God, you son of a bitch.
no, but partially too, I think this presentation is more than anything I know. It's all.
I thought it was sweet. The whole talk about isolating different strains and stuff was awesome. This whole stuff, I've never done a seltzer, but this is all great. But I just want to say that I love you guys' strains. Your Bach Yeast has made 2 of my top 3 favorite beers I've ever brewed in my life, just from one pitch. And it's awesome you guys are in the Midwest, so keep on doing what you're doing. It's freaking badass. That's all I'm going to say.
Oh, well, I like to hear nice things like that, so thank you. It's better than the random home brewer that will email us and swear at us. It happens.
Sorry.
I just have a little question about the proper seltzer nutrient. I was wondering how they might work on ciders like apple or pear. Yep. I know there's some controversy, discussion about the blend of the nitrogen sources. Just curious if you guys have tried that.
We've tried them on mead, so neither of those things, but it worked really, really well on mead. So I have a longer presentation that's really dedicated to the seltzers. One of the things we do talk about is it seems more prevalent in those realms like mead and wine and things like that, where they'll do staggered additions of nutrient. So they'll add half their dose at pitch, and then they'll wait, 24, 48 hours before they do their second dose. And we tested that and never saw a benefit. I mean, even very high gravity fermentations, we didn't see any benefit. So, and frankly, it's much easier to just do a single addition and let her rip. So I haven't studied in depth the literature as to, I think there are reasons why they do that, and, it might be a strain specific sort of thing. But with the ale yeast that we've used, there doesn't seem to be any sort of benefit from staggering nutrient additions. And I do think it would work well with cider. What I don't know without doing more experimentation is dosages. I don't know that much about apple juice as far as its nutritional, where you're starting out, like how much nitrogen does it have itself, how much, vitamins, things like that. So my guess is there's at least some of these things in there. So you can probably, cut back on our recommended dosages, but not something we've looked at. We have looked at mead, which is effectively just, sugar. And it does it at the same rates that we're using it for hard seltzer. It works well in mead.
Do you know what the suggested retail price is going to be for that off the top of your head, or no?
Oh, I don't remember. $4.99, $5.99, something like that.
Yeah, $5-6.
Yeah,
that sounds great.
And yeah, then just add sugar and flavoring. That's it. If you're a commercial brewery, I think the 7-barrel pitchables will be like $49.
Yeah, we don't have our resident pro brewer online. Otherwise,
Drew's on, so he's.
Well, that's
Mr.
there's our potential.
He's getting there. Yeah.
Yeah.
But don't the brew brewers have to use a certain percentage of barley though in Michigan? I think that's the case. I don't think they can ferment straight sugar.
They can. It's considered a sugar replacement.
Okay.
Yeah.
Yeah, it does seem like there's been a lot of, they've kind of gotten pretty relaxed on these sorts of things. It used to be where you had to have some amount of barley or something, but they've kind of gone away from that. But yeah, there's obviously a lot of state differences. So I'm definitely not going to give any advice on what your particular state allows.
When did you say that the proper seltzer was going to be released?
So we are utilizing a co-packer for this, and they are driving us nuts. So we're waiting for the packaging for a while. So it's just stupid logistical things right now. But we were supposed to have it in-house by this week. So I think next week we're supposed to have it, but then of course we'll have to send it out. So it'll take hopefully sometime in November you start seeing it show up at places.
Wait, sorry, I wasn't looking for like an exact date or anything. I realized that this year's like kind of odd. So
yeah,
problems.
Right, and that's obviously been part. I mean, just logistics for lots of things are kind of screwed up. I mean, packaging has been more difficult this year, and actually, we will be able to get it directly from us too. I think we're going to sell it in like 6 packs or something like that, that you can buy directly from our online shop. Same, though I'm not sure exactly where. With it, it's probably going to be like a overarching proper type store where you can get proper starter and or proper seltzer.
Yeah, we actually have one of the local homebrew stores in the area carries a pretty extensive Omega range. So, sorry, Omega. So I have reached out to Dane down in Vicksburg to tell him to keep an eye out. So,
yeah, be there soon.
Before you go, since I'm taking notes for the crew here, what was the name of the company that made your brewing equipment? Because that's that mash tun thing sounded really interesting, and you never know. We've had 2 people from this club either start a brewery or about to start a brewery, so you never know when someone's going to buy equipment. So what was the name of that company? If you don't mind.
Yeah, it's Aegir, AEGIR, Aegir Brewing Systems.
So
sounds
kind of
like
Griffin Claw uses that same one, I'm pretty sure.
Yep, exactly. Okay. Yeah. Griffin Claw has that same version of the mash filter and then the slightly bigger one. And Goose Island in Chicago has, they don't have an Aegir system, but they've got that mash filter. So Mira is a Belgian company. They're the ones that make the mash filter. And Aegir makes the rest of the brewing system and integrates everything. So it's all very automated too. It's a pretty nice system.
So that was going to be my question about that was what was the deciding factor to use that as opposed to like a regular lauter tun? I mean, was it just strictly the efficiency and like you just figured you would recoup the cost? I'm assuming it's probably more expensive than a traditional system.
Well, it isn't really. So with I mean, for example, we've got stuff spec'd from Sprinkman in Wisconsin, and their same size brew house with a traditional lauter tun was just as much as this system. I mean, I didn't even know anything about. Well, I had seen one before, but hadn't been considering it until our R&D director, Laura, was the brewmaster at Tennessee Brew Works before she moved to Chicago. And they had a Aegir system with the Mira mash filter. So she was like, hey, you should consider this. And I talked to them, and we worked with a lot of companies, obviously, and subs and contractors getting this building up and going. And they were and still are by far the best people we've worked with. They're very responsive. They've modified things, the way we were looking to have them modified. They've been awesome to work with. So if anybody is in the market for a brew house, I would, definitely recommend them. But yeah, very high efficiency. So yeah, you get, it pays for itself for sure. Getting 100% efficiency.
Well, and so for the other folks in the club who haven't gone to like Griffin Claw or whatever, when I went on the tour there, they said they basically grind their barley down to like flour, right? And then it's just like when they expel it, it's just kind of like, a mushy flour kind of stuff because there's no water. It's just flour, basically.
Yeah, so we, instead of a roller mill, we have a hammer mill. So it'd be kind of like the same thing a distillery uses. So it pounds the malt through a sieve instead of, between rollers. So definitely, it's not quite flour, but it's definitely more fine than you'd find from a roller mill. Because, roller mill, the whole point is to keep those husks intact to act as the filter bed, and that you don't need that for the mash filter. So it is very fine. It's not, water free when you come out, but certainly much less water. I don't know what somebody else might know what at a good brew house, what the spent grain water percentage is. It's probably at least 100% or over 100%. I'm not sure, probably over 100%. But so this ends up, I think, at 70% moisture. So basically the weight of grain that we put through the system ends up being the same weight that we get out, which is, it doesn't sound great, but it's actually much less. A normal lauter ton would weigh, the grain coming out would weigh a lot more than the grain going in because of all the water uptake. But we put 1,000 pounds of grain in, we get 1,000 pounds of spent grain out. We basically replace extract with water.
Right. Oh, sugar.
Yeah.
Interesting.
So back to yeast. Before you disappear, you hinted at what's on the horizon for hybrids.
Yeah, we've got some. So whenever we're sampling, we're doing these blind tastings all the time, and one thing that's kind of frustrating is we'll do a hazy recipe to test strains that we think are going to be good for hoppy beers, and we always include our British 5, which is it's like 25% of our production because everybody's making hazy IPAs. And we always include that as a control. And every time we do this, the beer I pick out, I'm like, oh, I really like this beer. And it's like, it ends up being British 5. I'm like, God damn it. Rather than like a new strain that we're trying to develop. Just this last week, that didn't happen. This is the first time that the strain I picked that really stuck out to me as being one I really liked was not the British 5. It was a big moment. So this literally just happened this week. So this was not, we'd have to do more testing with that. But it is actually a hybrid of British 5 and a wine yeast that gave some very interesting results that, I was super stoked that the first time I found a strain I liked better than British 5, but we're pretty early in that process.
Awesome. David, we had collected some questions on the website. Did we already cover those?
I forwarded those to Lance earlier.
So there was H2S.
H2S, yeah. I wasn't sure how many of them were strictly no, how many of them are really appropriate for this, considering how to suppress H2S formation probably isn't anything that it's nothing omega related, but I guess omega.
Well, yeah, and it's
I'll get it right one day.
Yeah, and it really is. It's kind of a hard question too, because it's super strain specific. They're lager yeasts are generally more prone to it, and that's just because they're genetically more prone to it, and because you tend to do colder fermentations with those, so it's just not as robustly blowing these things off. So strain specific. Hefeweizen strain, for example, makes a ton of it, and there's not much you can do to prevent it. But the good thing about H2S is it does tend to, if you've got a robust fermentation, it will blow off. So I think, the general idea, the healthier your fermentation, the less likely it's going to be a problem because, the fermentation is very robust and it blows off. And it generally conditions out to, it's a fairly reactive species too. So just given more time, it'll react with other, compounds in the beer to kind of minimize and get below flavor threshold. But so I guess the only real general advice I can offer would be to, just to have healthy fermentations. But I don't think there's a magic bullet for it.
Yeah, and the other two questions we had, there was the one about why do yeast manufacturers recommending pitching brand new yeast at much lower pitch rates, at about 500,000 cells per Plato. sorry, 500,000 cells per mil per degree Plato, but the general recommendation is 1 million cells.
Yeah, I mean, I'd say probably because, I mean, when we, especially the way we do our system with Pro Brewers, we custom propagate everything. So we don't make large batches that sit on a shelf for, 2 months before we ship them out. So it's as healthy as can be when we ship it to a professional brewery. So I think, starting with very vital and viable yeast gives you a little bit of leeway that way. And if we're shipping more yeast, we have to charge more, and a lot of breweries just don't want to. They're looking for, the ability to cut down costs. But we also don't force anybody to take any particular pitch rate. I mean, we everything's very customized. So when they order from us, we prop what they ask for.
Yeah. And the last question had about general recommendations on how to maximize ester formation, but you covered that earlier with your it depends.
Yeah, absolutely. It depends. Strain dependent, grist dependent, temperature dependent. That's something we definitely plan on diving into in more detail when we have gas chromatograph, where we can, I mean, it's one thing to have a panel of people smelling things and giving us opinions, but I'll feel much better when we can have a machine, do something more objective. So there's a long-term goal of ours is to get better characterization of our strains under a multitude of conditions. So there's not too much I can offer at this point, but it's something we are interested in.
I've got one more. This is probably a follow-up to something I think I probably asked earlier, but early in the presentation, you showed the plates where you were stressing the yeast at different temperatures. So you were the one that you had down at about 40 odd Fahrenheit, and the one that you had closer to about 100 or like over 100. You said that some of the things like hothead and the Hornindal and that they were still thriving at the there you go. Yeah, the Voss and the Hornindal are still thriving at 107. They're still doing pretty well at 46. Do you see any, what's the typically, what would you say would be a flavor difference there, or is that very much a case of, as you answered a little bit later on, I think, it's as we said, it depends on.
Yeah, and so we haven't. I don't think we've ever taken that's something we should put on our list, is making a beer with Voss or Hornindal at 50 Fahrenheit to completion like this. We did this plate test, but we've never gone through the whole process of making a beer under that condition. My guess is it's certainly not going to go any faster than a lager yeast, so there's probably I mean, if it did, that'd be great, because then there's a selling point there, like you can get even more lager like faster, but my guess is it's going to grow at best as fast as lager yeast. So, which actually wouldn't be a super shocking result. I think one of the things that came out of the big giant study about yeast genetics and comparison between strains is that there were a couple of yeasts that people thought had assumed were lager yeast that when they dove into their genetics ended up being ale yeast. But they've historically been used at cold fermentations to make lager beer. It really shows you how kind of hazy the lines are between all these things, because these were like production lager strains, but they ended up just being Cerevisiae that happened to be cold tolerant. So it's the lines are hazy with these things.
Is there any more questions for Lance? I'll take the silence as a no.
Thanks for taking the time.
Before people start bailing, please hang out. We've got some club business to go over real quick.
All right. Well, thanks for the opportunity to talk to you guys again.
Thanks, Lance.
Yeah, thanks. for
Awesome,
coming.
Lance. Appreciate it. Thank you.
Thank you, Lance.
Yeah.
Enjoyed the presentation.
All right, stay safe, everybody.